For the law of sines, what we are trying to do is figure out either a missing angle or missing side length, and it really depends on, um, what if you're looking for x or you're looking for theta. Okay, the idea behind the law of sines is that you have three sides and three angles of a triangle. The lowercase letters represent side lengths, so you have side A, side B, and side C. You also have angles A, B, and C. The law of sines simply says that the sine of A, which is angle A, over side length A, that ratio is equal to the same ratio of sine of B over B or sine of C over C. You can also flip it and put the side length on top and the sine of the angle on bottom. It really doesn't matter which way you do it. You're probably going to do it a consistent way, but that's going to depend on kind of your preference. You only need two of these to make an equation. So it might be using side A, side B, angle B. And you might not have to use this part. So you're only going to typically use two of them. And you use this when you have two angles and then a non-included side, or a side between two angles, or two sides and a non-included angle. So what we're going to do is we're going to look at these problems below here as ways to find either angle theta or side x, and we're going to go through them, and then I'm going to give you an opportunity to do two of them on your own. So we'll do four of them together, and then you can try two of them on your own. The first one that we're going to try is letter A, okay? And we're looking for angle theta. So because we're looking for an angle theta, we want to figure out what is theta across from. And theta is across from the 22 meters, okay? So we're going to use 22 across from angle theta. So when you set up an equation, the way that this equation is going to work is you're going to set it up. I typically go side length over the sine of the angle, and you're going to set it up as a proportion. So you're going to say 22, which is the side length, divided by the sine of theta, which is the angle. Okay. And then you're going to set that equal to another side that's across from another angle. So the other side that I can see in this picture is 17. And 17 is across from the 42-degree angle. So we're going to write sine of 42 down here. Okay. Now at this point, what we want to do is we want to cross multiply and then divide. So when I look at this, what I'm looking for is angle theta. So angle theta connected to the sine of theta is across from the 17. Those are diagonal. And then 22 and the sine of 42 are across from each other in this diagonal. Because theta's here, we're going to use this diagonal first, these two, 22 and the sine of 42, and we are going to multiply those two together. So I'm going to grab my calculator and I'm going to type in 22 times the sine of 42. And when I do that, when I take 22 times the sine of 42 degrees, I get 14.72. I'm going to take that 14.72 and I'm going to divide by the 17 that's here by itself. So I'm taking that 14.72, I'm going to divide by 17, and I end up getting this decimal. So basically what I'm left with is sine of theta. So I'm going to say sine of theta equals 0.8659. Okay. Now, I don't want the sine of theta. I want what actually theta is. So in order to figure out what angle theta is, we've talked about this many times. Whenever you're looking for an angle, you have to use the inverse. So you're going to take the sine inverse of that decimal, and whatever your calculator kicks out, that's going to be the measurement of angle theta. So I'm going to take the sine inverse of 0.8659, and I would suggest that you grab your calculator and do the same thing. Take the sine inverse of 0.8659. So second sine inverse 0.8659. And I end up getting 59.985, so 59.99 degrees. So this angle theta right here is approximately 59.99 degrees. Okay. So now that I have my angle theta, I am done with letter A. We're going to move on now to letter B. So for letter B, the way that it is set up, we are looking for side length x. And side length x is across from this angle, which is an issue because if we don't know what angle it's across from, we can't use the law of sines. But what's really nice about this problem is because two angles are already given, I can take 180, I can subtract 35, and I can subtract 88, and that leaves me with 57 degrees. So that means that this angle right here is 57 degrees, and now I can use the law of sines. So I notice that side length x is across from 57 degrees. So I'm going to set it up as side length x. I always do side length on top and then the angle on bottom. That's just my personal preference. You can do whatever way you want. Side length x over the sine of 57 degrees. Okay, so sine of 57 degrees, okay, equals. Now, when I look at it, I need to find another side length and an angle that's across from it. So these two happen to be across from each other. So I'm going to use the 44 on top because I used the side lengths on top. So 44 on top. And that gets divided by the sine of 88, which is the angle across from it. Okay. And again, because I see the x here, the x is diagonal from the sine of 88. So I'm going to use the other ones where the x is not, and I'm going to multiply those first. So I'm going to multiply 44 times the sine of 57. So I'm going to grab my calculator, and I'm going to take 44 times the sine of 57 degrees, and that's going to give me 36.90. Okay, so I end up getting 36.90. And then what I'm going to do is I'm going to divide by this extra piece. So you always divide by the extra piece. So I'm going to take that 36.90 and I'm going to divide by the sine of 88. And when I divide by the sine of 88, I get x is approximately 36.92. Okay, and to me that seems very reasonable because it does look like it's a little bit shorter than this 44, and 36 is a little bit shorter than 44 for a side length. Okay, so I've showed you one where you find an angle and one where you find a side length. So we're going to use that to try to find C, which is an angle theta, and we need to know what is across from it. So angle theta is across from the 6, and 9.4 is across from 51, and we can use that to set up an equation. So I'm going to say 6 divided by the sine of theta, because those are across from each other, is equal to 9.4 divided by the sine of the angle that's across from the 9.4, which is 51 degrees. So sine of 51. Notice how for all three of these, we've used sine, hence why it's called the law of sines. Okay. So when I look at what I'm looking for angle theta. Angle theta is diagonal from 9.4. So I'm going to avoid these two right away, and I'm going to use these two to multiply. So I'm going to take 6 times the sine of 51. Okay, so I grab my calculator, I take 6 times the sine of 51, and that gives me 4.66. Okay, so I got 4.66. Then what I'm going to do is divide by this extra piece of information. So I'm going to divide by 9.4. So I'm taking that 4.6628757769, that 4.66, I'm dividing that by 9.4. And that gives me approximately a sine of theta. Okay, so sine of theta, which is what's remaining up there. Okay, sine of theta is all by itself. Sine of theta is equal to 0.4961. Okay, 496, and it's actually 0.5, so 0.5 rounds this up to a 1. Because I'm looking for angle theta, I'm looking for an inverse. So I'm going to use the sine inverse, okay, to figure out angle theta. So I'm going to take the sine inverse of 0.4961. Okay, and I'm going to grab my calculator and I'm going to type in sine inverse of that. So second sine inverse 0.4961. And I end up getting approximately, so this angle, angle theta, is approximately 29.74 degrees. Okay. So I've showed you two examples where you're looking for angles. Now I'm going to show you one more example where you're looking for a side length, and we'll do that on letter E. So because we're looking for a side length on letter E, we need to figure out what's across from that particular side for X, since we're looking for side X. Side X is across from 61. Okay, so we know that that's the pairing that's going to go together right away. So I'll just write that. X, which is the side lengths go on top, divided by the sine of 61 degrees, okay, equals, now I need to find another side length, which I notice is 21, but again, we have an issue. 21 divided by the angle that's across from it. Well, if I go over to here, there's no angle there right now, but we can figure it out pretty quick because the triangle angle sum theorem says the three angles of a triangle add up to 180. So if I take 180 and I subtract 48 and I subtract 61, I get 71 degrees. So that means that this is a 71 degree angle, and that is what I'm going to use for the sine of the angle down below, because that's what the law of sine says. So law of sine says take the sine of the angle across from that side. So that'd be sine of 71 degrees. Now, again, I look at this and I go, okay, the x is what I'm looking for, and x is diagonal from sine of 71. So I'm going to ignore those right away, and I'm going to take the two that actually I have value, and that would be 21 and the sine of 61. So I'm going to take 21 times the sine of 61, and that gives me 18.367. So 18.367. And now I'm going to divide by this extra piece of information. Okay, so I'm going to divide that by the sine of 71. So divided by sine of 71. And because we're looking for a side length, there's no need to take an inverse, and this should give me my x value. X is approximately 19.425, so we'll say 19.43. Okay. For letter D, notice how these are across from each other and these are across from each other. So you're going to set it up using that. And because you're looking for theta, you're going to use an inverse at the end. And then for letter F, because X is across from this angle right here, you need to figure out what this angle is, because that's across from X. And that means that the 45 is across from the 52. So you're going to set it up as 45 divided by the sine of 52 equals X divided by the sine of this angle. And to figure out this angle, which is a very small angle, you're going to take 180 minus 118 minus 52, which would give you a 10 degree angle. So this would be 10, and that's across from the side length X.